Hello, this video is another kinematics question where we're going to have a look at frames of reference. We've got an aeroplane flying in the air that's moving due east at v meters per second. So that's the air is moving due east. Relative to the air, the aeroplane has a velocity of 90 meters per second due north. And during a 20-second period, the motion of the air causes the aeroplane to move 240 meters to the east. Okay, so we've got two frames of reference again. I'm going to set up the orientation of the axes because they're not going to be changing. So if we've got north and we've got east, and I'm going to write these in column vectors, all of these velocities with east at the top and north at the bottom. So this is how I'm going to be, the notation I'm going to be using. We've got three things that we need to consider. We've got the air, we've got the ground, and we've got the aeroplane. So let's see what the velocity of each of these three things is in each frame of reference. So we've got the frame of reference of the air, and we've got the frame of reference of the ground, because they've given us bits of information relating to each one. First of all, we can always say that the velocity of the air with respect to the air is going to be zero. So if we're in the frame of reference of the air, then the air is moving at 0, 0. Similarly for the ground, in the frame of reference of the ground isn't moving. Now the other things they've told us is, so in the first sentence, we've got the air is moving due east at v meters per second. So that is saying that in the frame of reference of the ground, the air is moving v east. We've also been told that relative to the air, the aeroplane is moving 90 meters per second due north. So in the frame of reference of the air, the plane is moving at 0, 90. Now, if we're going to then fill in these other two velocities, one in each of the two frames of reference, all we've got to do is the same translation on each one. So we can see that the v in the east component is dropping by an amount v when we move from ground to air frame of reference. So the ground in the air frame of reference is going to be at minus v. The north component isn't changing. And as we go from the frame of reference of the air to the ground, we're adding on v to the east component. So the plane will be at v90. So yeah, I mean, this is just a different way, again, of describing the sort of stuff that we do without thinking when we answer these questions. So we're saying, oh, right, okay, so if the air is moving that way and the plane is moving that way, then we combine them and we get a result in that direction. But it just gives us that opportunity to step into this idea of frames of reference and make our first steps along that path. Right, so let's just quickly go through these questions. So we have to find what v is. Well, it's moved 240 meters in 20 seconds, so we just got to divide 240 by 20. So v is 12 meters per second. Find the magnitude of the resultant velocity of the aeroplane. That's going to be in the frame of reference of the ground, so that's at 1290. So we need to add square root. So that's going to be the square root of 8,244. Yeah, I'm going to put that in the calculator, even though I could start pulling out some factors, but I'm not going to. That is 90.8 meters per second. And then we've got the direction of the resultant velocity. Given your answer as a three-figure bearing, right? Okay, so we've got we want this angle here essentially, and that angle. So the tan of the angle is going to be the opposite, which is 2. So we've got 2 from 12, and divided by 90. So we just need to plug that into the calculator and get 8 degrees is the nearest. So 008 degrees to write it as a three-figure bearing as they've asked. So the question itself, yeah, is pretty straightforward. like I say, we're just looking at this bit really to see frames of reference in their beginnings.